Hi again. I think I already wrote in that color. Probably should pick this color. You know which one it is. Probably should pick this color. And hmm, we'll see. Maybe this one. I'll put that one there just in case. Okay, so today we're going to talk about section 5, classwork. That's us. So the first thing we're going to talk about is angle pairs. And in these angle pairs, there are a couple of different versions, and these are not all the versions. It's just some of this stuff I know you already know because I did it when we were in algebra, but some of this not so much. So complementary angles, I know you know, adds up to 90 degrees. So if this is one of those definitions you already know, then you don't need to write it down on your definition sheet. However, if it's not, make sure that you do. If you will remember when we did complementary and supplementary angles, I told you that you always need to draw a picture because it's geometry. You draw a picture for everything in geometry. So my picture that I default to whenever they talk about complementary angles is this one, so that you can see that it's 90 degrees. That's why I use that one. So supplementary angles add up to 180 degrees. The picture I default to is something like this, where you can tell that it's going to be 180 degrees because it's a line. So that's that. You need to keep in mind that just because they're complementary and supplementary, and just because I draw them as adjacent angles, they do not have to be adjacent angles. They can be separate individual, one side of this board and the other side of this board, and still be complementary or supplementary, because all complementary and supplementary mean is that their measures add up to those numbers, not that they are side by side or that they form a special angle. Okay. However, linear pairs, I'm underlining for a reason. Linear pairs also add up to 180 degrees, and they do have to be adjacent. I promise you, somewhere in your theorems / definitions, that's an easier way of saying whatever their definition is. Promise you. So that kind of thing where we would have linear pairs, because they're linear pairs, be our reason, and that would be our reason for saying the two angles add up to 180, because they're linear pairs. Last time we did this, we had to use two different reasons. Now we can just say they're linear pairs and not have to worry about those two different reasons. So that's why we want to try to keep things short. And as we go on, we'll be able to shorten things even more every single time. So we went from two reasons last time to just one reason now. So we've already shortcutted stuff already. These do have to be adjacent. They have to be side by side because they have to form that line. It's that line that makes them a linear pair. So the fact that we know about this is that angle ABD and angle DBC are a linear pair. Now that we know that, we can say that angle ABD plus angle DBC have to equal 180 degrees because they're linear pairs, definition of linear pairs. Okay, so all that being said, what if I were to say that this angle was 3x and this angle is 2x? And then what if I were to say, find the measure of angle DBC? Just like we did yesterday, because it's going to happen every single time. Just like we did yesterday, when we do this, you need to start in your mind by thinking of all the things you know about this that's true. So I'm going to write step 1. Ask yourself, what are some things I know about this picture? And then step 2. Which of those things will apply to what they're asking? Those are the 2 things that I do in my head. Those are the 2 things you're going to need to start doing in your head. So I know I'm making this like super simple for you, but please just go with it a little bit of easy, never hurt nobody. So when we're doing this, one of the things you tell me that you think you should know is that these 2 angles are a linear pair, and that because these 2 angles are a linear pair, they have to add up to 180. So that means that the measure of angle ABD plus the measure of angle DBC has to equal 180. And then we can substitute in what we know about the measure of angle ABD. That's that it's 3x, plus substituting in what we know about the measure of angle DBC. That's that it's 2x. That has to equal 180. Then we know that we need to combine our like terms to get 5x equals 180. Then we can divide both sides by 5 to get that x is equal to 36. Is that my answer? No, because I taught you well in algebra, and you know that x is very rarely really your answer. You have to go and plug it back in. So that means that 2 times 36 is what this angle really is. And 2 times 36 is really 72 degrees. And that is the answer. And that is why I boxed. Now, I don't expect you to write this down every time. I don't expect you to write what the answers to these are down. But these are the things you need to be thinking about when you're trying to set up these problems. Because it's not always going to jump right out at you. Sometimes it takes a little bit of inclining, especially the more rules we get, the more laws there are, the more postulates and theorems and corollaries and definitions. It starts to pile up after a while. And you've got to keep it all fresh in your mind every single day. So you want to keep making sure you go back and you look at that definitions page and you go back and you read over that postulate page so you can remember what those things are. That's why I had you put them in your words and not in their words. Because if you put them in your words, that means you had to think about it enough to write it down. You had to kind of understand it to write it down. If you put it in their words, then you're just copying something. That's not really helpful. That's just copying. Okay, so far we have complementary angles for angle pairs, supplementary angles for angle pairs, and linear pairs. Now let's talk about the one that I like the most, which is none of these. I bet you're looking ahead to find out what it is. It's just like you to do something like that. Trying to take the fluff out of my fun. I should just change it up just to get on your nerves. But no, I'm going to be nice. My favorite kind is vertical angles. So I'm going to explain to you what vertical angles are, but I'm not going to give you a definition of vertical angles because it's easier for me just to explain it and you'd be able to figure out what it is. Because usually when you're talking about vertical angles, they're not telling you they're vertical. You're looking at a picture to see that they're vertical, just like you look at a picture to see that it's a linear pair. So for vertical angles, this is kind of what it looks like. They cross in the middle. Let's talk about this like it's angle 1, 2, 3, and 4. You can kind of see that. And let's put some some letters up here so I can talk about them. So A, B, C, D. And if I want to talk about the middle one, it can be O. I doubt I will, but if I wanted to, we'll call it O. So, vertical angles. Some people say that vertical angles are opposite of each other, but that's kind of hard to explain. Vertical angles have to be formed by lines. So the line AB crosses the line CD, and it forms some vertical angles in there. Not all of those angles are vertical angles. So you have to talk about the angle pairs themselves. So angle 1 and angle 3 are vertical angles. And then angle 4 and angle 2 are vertical angles. They're kind of across from each other. Whenever you have two lines that cross, and you have to have two lines that cross in order to get vertical angles, whenever you have that, you don't end up with just one pair of vertical angles. You'll always end up with two pairs of vertical angles. It's going to happen. Two pairs of vertical angles. I'm not allowed to say what I want to say, so I don't know what to do. Okay, because we're not there yet. We're going to get there in just a bit, but we're not there yet. Okay. Let's talk about a different picture. Let's say I had this kind of picture, where this was still my O, and this was still my A, and this was still my C, and then I had this. And this was my B, and that was my D. Technically, these two angles are still opposite each other, but these are not vertical angles because they are not straight lines. They have to form straight lines in order to make vertical angles. So none of these angles, even though some of them are across from each other, are going to be vertical. Okay. Not vertical, vertical. Once again, we're talking about the space in between the lines. Those are our vertical angles, not the actual lines themselves. Ooh, do I need the picture? No. Not going to do that. Got a different picture. Okay. Now I get to say it. Are you ready? The thing I've been holding back for a while now. Vertical angles are congruent. it is by far, and I don't know why, I'm weird that way, I guess. It is by far my absolute, positively most favorite postulate, theorem, whatever, ever. I loved this. It made things so simple. You knew you could just draw those lines and move on with life. Little tick marks were everywhere on the paper. It made things go so fast. It's a fact, and you know that you can take it as a fact, and you can use it, and it's right away, and its vertical angles are congruent, and it's not long to right. It was beautiful. That was back when I was in 10th grade. A long time ago. Okay. That's the postulate slash theorem slash shortcut that I'm giving you this particular class. Let's look at a picture. Call that C, B, A, D, E, and then the middle one is O, and that's angle 1, angle 2, angle 3, angle 4, and angle 5. Now, I'm going to write up some things that I want you to do. I want you to do it on your classwork thing. I'll give you some time. I'll actually sing to you. Okay, I'm not really going to sing. But you can pause it and get some time. But I want you to time yourself to see if you can actually find these yourself before we go on. And then I'm going to give you the answers to them. That's why you're doing them in your class notes. Okay, so give me a second to write them down, and it shouldn't take more than a second. See, I told you it wouldn't take long. Now you can pause the tape and try those and time yourself and see how fast you can get the answers. And if you get stuck and you don't know anymore and you've gone through all 5 and you think you're done with all you know, go ahead and start the tape back and I'll go over the answers. Okay, let's do this then. So it says to name 2 vertical angles. That means they have to be opposite each other, made with the same line. So that's only going to be angles 2 and angle 4. Those are the ones that are opposite each other. If you use the letters instead of the numbers, that's fine. Just make sure you got the right ones. And then it says name 2 complementary numbers. Complementary angles. So complementary angles means they have to add up to 90 degrees. Well, if this one is 90 degrees, then that side has to be 90 degrees. That's going to be angle 2 and angle 1. And then name 2 supplementary angles. Well, since I was very specific in 2 supplementary angles, that means they have to add up to 180. And it doesn't matter which ones you give as long as they add up to 180 and you're only telling me 2 angles that add up to 180. So if you wanted to, you could say angle COA, that's the big one, and angle 5. Or you could say angle AOD and angle 1. Or you could say angle 2 and angle 3. Or you could say there's a whole bunch of different things that you could say. I'm going to stick with the angle 2 and angle 3. Just make sure there's a straight line there because that's what 180 is. And we don't know that any of those other things actually add up to 180. Now, name a linear pair. This one's specific. It has to be only 2 angles because they said it was a pair, and they have to be side by side. I want to use a different one from what I used up here, so I'm going to say angle 3 and angle 4. And then the conundrum. Bum, bum, bum. Could you do it on your own? Oh my goodness. So if angle 1 is 60 degrees, now see, they're giving me information. And when they give me information, the reason you write a picture is so you can put the information in the picture. It helps. So if angle 1 is 60 degrees, they want me to find angle 3. Okay, let's think about this. Miss Rogers said I'm supposed to think about all the things that I know, and we have already listed out some of the things that I know. But then I'm supposed to think about which of those things is going to help me get from here over to here. Well, in our list over there, we said that these two angles were complementary, which means that they have to add up to 90 degrees. So since these two angles are complementary and add up to 90 degrees, that means this one must be 30 degrees. That's cool. I'm all right with that. But we also said over there that that one is vertical, so I could come down here and mark those as being congruent because vertical angles are congruent. She said that. She also said that these two angles were supplementary, so they had to add up to 180. And she said that these two angles were linear pairs, so they had to add up to 180. So it doesn't matter which way I do it, because this one's 30 degrees. Doesn't matter whether I do it this way, with those two equaling 180, or if I do it this way with these two equaling 180. Either way, 180 minus that 30 degrees gives me 150 degrees for angle 3. The measure of angle 3 equals 150 degrees. Ta-da! Good job. I know you probably got it. It might take you a little bit, but I know you probably got it. So that's part of what I wanted to do. Now I want you to look with me on page 25 and let's talk about some stuff. Because on page 25, look, I'll slide over a little bit so you can see the face. Isn't that sweet? On page 25, they have some true or false where you're supposed to justify your answers. And starting in this section, and definitely going into the next section, they do this whole thing where they start calling things by the theorem numbers and the corollary numbers, which is one of the reasons why I wanted you to write it down so you could tell, but we will never call them by that. Ever, never. That's bad form. And the reason it's bad form is because just because they're that number in this book doesn't mean that they're that number in every other book. And we want to say that we understand and that we can communicate that to somebody else. So you need to make sure that you know how to say it without theorem 1.2 and corollary 1.5. So that being said, when we go through this, we're going to say why we know those things and whether or not it's true or whether or not it's false. And I'll try to draw some pictures so that you can kind of understand where we're going with this whole true false thing. So looking at number 6 in the class exercises, page 25, it says complementary angles are always adjacent. Are complementary angles always adjacent? No, they don't have to be adjacent. I told you that. They could be on separate sides of the board, separate sides of the picture, separate sides of the book, And they could still be complementary because all they have to do is add up to 90 degrees. So the reasoning is they can be anywhere. That's what the book says. They don't have to be adjacent. Supplementary angles are always adjacent. Is that true? No. But if they are, we call them a linear pair. The angles of a linear pair are always adjacent. True? Yeah, I just told you that one. See how I just give stuff away? It's difficult being me. That's by the definition of linear pair, by the way. A complement of an acute angle is acute. If it's a complement, that means it has to add up to 90 degrees, right? So if it's an acute angle, it's less than 90 degrees, and its complement is going to have to be less than 90 degrees too. So that's true by the definition of acute angles and 90 degrees. So a supplement of an obtuse angle is acute. Well, looking at a picture. We'll do this one. These are supplements. The supplement of an obtuse angle, this one was the obtuse one, is acute. Well, if the supplement of an obtuse angle was obtuse, then it would add up to more than that 180, and therefore it wouldn't be a supplement anymore. So that must be true by the definition of supplementary angles. The supplement of a right angle is a right angle. Oh, I skipped one, sorry. The supplement of an acute angle is acute. Well, that's got to be false. Because if you got something less than 90 degrees and you're adding something less than 90 degrees, then that's not going to make you 180. Excuse me. Hold on a second. Okay, number 12. The supplement of a right angle is a right angle. That one's true, because 90 plus 90 is 180. Definition of supplementary angles and right angles. Vertical angles are sometimes adjacent. Can they ever be side by side? No. Because technically, by definition, those vertical angles have to be across from each other, formed by a line. You cannot say that this angle and this angle are vertical angles. Even though they're formed by that line, they have to be the ones that are directly across from each other to be vertical. Okay, number 14. If two angles are vertical, they are either both acute or both obtuse. True or false? I know your hunch is to go with true. Because what else could they be? Either they're both acute because they have to be the same, or they're both obtuse because they have to be the same. But there is one other choice. So the answer is false. Because they could both be right. So you could have two right angles, and they are still vertical. Give me a second. Could have two right angles. They are still vertical. Still made up with lines, and 1 and 3 are vertical. But they are right angles. They are not obtuse or acute. It can happen. Okay, so let's talk about classwork and homework. So classwork for this section came out of the book. It's out of the practice exercises. I turned to the back of the book and was like blown away by what they got back there. I could not believe that they had some even numbers back there. It was like, what are you doing? No book does that. Why in the world would they do that? And then they're so arbitrary as to whether they're going to choose an odd or an even. So I just went ahead and made a note of all of them in my book so I know where they were for this particular section before I assigned this. So all the answers here are in the back of the book, but for your homework, they're in the back of the book. But For the classwork, I actually went through and worked all of the classwork out, and your mom has a copy in the email of what the classwork answers were. And not only did I work all the classwork out, but I gave you a spot where there was a hint in case you just don't know where to start. You can read the hint before you get to the answer to see if the hint kind of spurs on you getting to that answer first. So you can read the hint and see, oh, that helps so much. And then go ahead and get the answer yourself without actually looking at the answer. Or if you just completely lost, I actually explained every single thing there. It's beautiful. You should read it sometime. I'm just saying. It's very pretty. So the classwork for this section is the practice exercises on page 26. Numbers 4, 18, 14, 21, and 27. And then the homework for this section, which will be a piece of cake after you go through all that classwork, are numbers 3, 12, 16, and 20. There's that. A little bit shorter today, but I think it explained even more. So make sure you've memorized what angle pairs are, what the different angle pairs are, and you might want to go ahead and put some of them on your definitions page. Make sure you go back and clarify your postulates page, and definitely put the ones that I've underlined there, and try to get it as short for each one as you can. Okay, bye.